Okay, so the topic of this video lesson is predicting the products of a single cationic displacement reaction. Okay, so cationic meaning that we're switching out the metals or the cations if the cation happens to be H+. So learning goals, going to investigate the different chemical reactions of elements and produce an activity series, which we did yesterday with our activity. We can write out a balanced chemical equation to represent, now this time we're going to be looking at single displacement mostly, and use the appropriate naming system, and then finally predict the products of a single displacement reaction using the metal activity series. Okay, so that's what we're looking at there today. Okay, so you're going to need a few materials, so you should have this sheet as well, okay, which is the periodic table with all the charges, and then also you should have this sheet which shows the activity series or the reactivity series, if you'd like to call it that way. This is roughly the order. This is the actual order. Your elements should have fallen in somewhere in this area. You know, they're a little bit different from each other, so from the experimental stuff that we did there with the acids, but this is generally the order of reactivity. So we'll need those two materials plus the sheet that you have here in front of you. Okay, so how do we do this? Okay, to start with, there's several steps that we need to look at. So first of all, when you're given an example, I'm going to give you an example here, so we'll write it down. So iron, you can see if iron is going to react with tin or chloride. Okay, so does it react? That's the question. All right, so how do we know if it reacts or not? Well, the first thing we want to do is see which one's more reactive in terms of the two materials that could be displacing each other. Okay, so here we're dealing with cations, so it should be the first part of the compound, and then also the element that that's on its own. Okay, the metal that's on its own, it should also be a metal. Okay, so these guys are going to be possibly doing some displacement. Okay, so that's the key thing. So so we check to see on this activity series whether or not the iron is more reactive than the tin. So if we look at it, iron's here and tin's below, so this one's more reactive than tin. Okay, that's what this means because it's higher on the series. So we identify the metals that are undergoing the displacement according to the activity series that the metal, which is doing the displacement, which is alone, is higher than the metal found in the compound, then a reaction occurs. And this is the case that we'll see. Okay, so the metal in the compound, if the metal in the compound's higher, which is not the case, there would be no reaction. Okay, so let's just take a look. So now we're going to do the displacing. So without the subscripts, replace the metal in the compound from the metal with the metal of the element that is alone. So here we have iron is going to displace the tin in the compound. So iron, chloride is our compound, and tin is going to be left out. Okay, so it's going to be displaced out. Now, as you can see, I haven't recorded any of the subscripts because I haven't figured out exactly what charge the iron is. Now, normally, if we're dealing with a representative element, what we will have is an element, a charge given to it already. The only problem with this one is it's a transition element, and iron has multiple charges. So which one is it going to be? Okay, so what we're going to do is we're going to look at the chart. Now the chart is organized in a way that the top element is, the top charge is the more common or more stable element. It does, and there's no rhyme or reason. It just happens that iron 3+ is going to be the one that's going to be produced rather than the iron 2+. Iron 3+ is more stable than iron 2+. Not that iron 2+ can't be produced, it just generally doesn't get produced. So having said that, so because it's a transition element, I got to double check I know it's going to be the more stable charged particle. Charge. Okay? And chlorine I know is 1 minus, okay, from the chart. So now I'm going to follow and get the correct formula. So it says, get the correct formula using subscripts and the crisscross rule. Identify the new charge on the metal in the compound. The non-metal or non-metal group retains the same charge. So how do I know what the charge was? Well, it was 1 minus, and this was 4 plus because of the backwards crisscross, if you want to call it that. Okay? So the tin becomes from 4 plus, it goes to an element which has all of its electrons. So there's an exchange of electrons between these two metals. All right, so it says to get the right formula, and it actually goes through here a little bit too. It says transition elements become the more stable charge. It's found the first or the top charge on the periodic table. It's not always the smallest or the largest charge. You must use that periodic table that I gave you to figure out which one it is. Okay, so crisscross. 1 here, so I'm going to leave it. 3 there. Now I've got the correct formula. It's iron 3 chloride, and it's tin as well. Okay. Now the final thing is to balance the overall reaction. So I'm just going to balance it like I normally would. Okay. So I've got 3 chlorines here, 4 there. I'm going to need to put a 3 here. 4 in front of the chlorines. That's going to cause me to balance the irons and the tins afterwards. Okay, so that's the method that we're going to use. So what I'd like you to try is this other example. Okay, so go ahead and try this. MgFe2SO4 3. Okay, and we'll just, you go ahead and try that, see if it reacts, try to balance it, and we'll check the answer in a few seconds. So I paused the video at this point. Okay, now we're back. Let's check to see if we got it right. Okay, without going through all the steps, magnesium is higher than iron, so we get magnesium sulfate. Okay, magnesium's 2 plus, sulfate's 2 minus, so I don't have any subscripts there. Iron gets displaced. Okay, so this one bumps it out, and now to balance, I need 3 here, 3 here, and 2 there. And that's my balance. Okay, last one we're going to try is with water. Now water is a little bit different, so we have to kind of write it a little bit differently. So HOH is the best way, so this is really water. If you leave it as water, you're going to probably not know what to do with it. So again, hydrogen is going to be the element that's going to be replaced. So if it's lower, then it's less reactive than calcium. Calcium is going to dump it out. And we saw this actually, this reaction, that's what produced the hydrogen gas. So calcium is higher than hydrogen, so it will displace. So I'll get calcium, and you see this is the anion, hydroxide. And this is 2 plus, and if I look on my chart, hydroxide's 1 minus, crisscross, I need a 2 here. And then hydrogen is what's produced. Now hydrogen, atomic hydrogen is never produced, so I had to double check. Hydrogen behaves as a metal. The compound is always a plus charge of 1. When it becomes an element, it is diatomic because it's a Hofbrinkel element. And then I just have to balance it. And I believe I'll need 2 of these, and that will balance everything out. Okay, one last one. What about if I have nickel and strontium bromide? Okay, well in this case nickel is lower than the strontium, so nickel is less reactive and strontium is more reactive, so this reaction actually does not happen, so we can just write down no reaction. And that is it. Okay, good luck with your activities. There's a worksheet. You should go through as many as possible. Some of them are already given with names, so you have to convert the names to formulas before you start this. Okay, thank you.